Okay, I am going to do a couple sample problems that are going to review quadratic modeling for the final. So I've got my calculator off to the side. You're going to need your graphing calculator because you're going to check your work, and make sure you've got a pencil ready. All right, the first problem we're going to do right here. I think you'll remember these from chapter 4. What we have here is the height of an object in feet is given by this equation. So this equation gives us the height of something in feet. And t happens to be the time in seconds. Okay, so what we're doing is we're throwing something, and this equation models its path. And we're plotting distance in feet over time in seconds, and it's asking us to find the time it takes the object to strike the ground and the time for it to hit its maximum height. So the first thing I'm going to do is I'm going to draw a little picture of what this looks like. And this is what this looks like. This is my height in feet. That's this side. And along here, t is my time in seconds. So I'm plotting distance over time. And we know that this thing is launched and it takes this kind of path. Whoop. Okay, I hope your parabola looks better than mine. But we've got two important points. One of them is our vertex. The other one down here is what we call our zero. That's our zero. This is where this thing's going to hit the ground. The vertex is either the max or the minimum height. So we're going to go out of order here. And it says, find the maximum height of the object. So the maximum height is going to be given by the vertex. In the vertex, the coordinates of the vertex are x comma y. And in our problem, our x-axis is time. This is going to tell us time, and our y-axis is distance. So this is going to tell us distance. Okay? So in order for us to find the vertex, we have to remember two formulas. First, we use x is the opposite of b over 2a. And once we figure out that x value, we plug it back into the equation. So this thing is equal to 0. This is 0. So I'm going to identify my values. A is a negative 16, B is 64, and C is 190. Okay? And so I'm going to go ahead and I'm going to plug in x is equal to negative 64 all over 2 times the negative 16. So I get a negative 64 over a negative 32, which simplifies to 2. So up here at my vertex, that's a 2. Maybe I'll put that in over here. 2 comma. And now we're going to use 2 and plug it in. And we're going to use that to find y. Okay, so we're going to find the y value of our vertex. So I'm going to take negative 16, I'm going to write plus 64, plus 190. Now I'm going to go back and I'm just going to change my pen color, and I'm going to plug in the number 2. So there's 2 squared plus 64 times 2. And I'm going to compute this out, and I need to find my key. So negative 16 times 2 squared should give you a negative 64. 64 times 2 is 128, plus 190. So when we add all this together, we get 254. So my vertex is 2 comma 254. That looks kind of messy. 2 comma 254. So the maximum height of this object is 254 feet. Sometimes we ask you when did this hit its maximum? When did it reach its max? Well, the when is answered by the x value, which is at 2 seconds. All right, I'm going to go get my graphing calculator, and we're going to use that to double check our work. Okay? So I'm going to pull this in, and I'm going to do some button pushing now. So on, and I want you to do this with me. I want you to type into your equation editor. We're going to type in negative 16x squared plus 64x plus 190. Hit enter, and now let's go look at the graph. So what happens is my graph is really, really zoomed in. I can't see the whole thing like I can over here. So when I come over here, I'm like a microscope and I'm zoomed in. I'm going to zoom out. The question is, how much do I want to change my window to move out? Well, I'm only really interested in the positive y-axis and the positive x-axis. So, and I see this 190 here. So maybe it might be helpful to go change my x max to 190, my y max to 190. I'm sorry, to see what that gets me. So I'm just going to try that. And remember, this is trial and error. Okay, kind of cool. That helps, but I don't get my vertex. So I'm going to go back to window, and I'm going to change my minimum. I'm not interested in x values in negative time, so I'm just going to do -2. And it looks like, was 10 enough? I forget. Maybe it was. My y minimum is height. I don't have a minimum height, but I do want to see this. I want to be able to see a little bit below. So I'm going to do maybe -5. And we said that 190 wasn't enough. Let's go up to 250. I'm going to change my y scale to count by 50s. And hit enter. Now let's go back to the graph. Almost. I need to go up a little higher. So instead of 250, I'm going to do 300. And hit graph. And you know what? Now that I'm thinking about it, I could have used this to help me out. 254 is my maximum, so I should have known that. Well, how do we calculate this with the graphing calculator? We're going to look for the maximum. Second, trace. We're going to go find a max. Hit enter. This blinky thing has to be moved to the left-hand side of the vertex. It says the left bound. Make sure it's left. Click enter. Use these arrows, the left and right ones, to move them over the hill. Click enter. Enter one more time. My maximum is 1.999254. I think we're pretty good. I agree with that. 159.254. So we were really close. This is how you do it without a graphing calculator. This is how you check your work. All right, now we're going to go answer the second question. The question says, how long does it take for this thing to hit the ground? So I'm going to, we need to answer, when will it hit the ground? So when will it hit the ground? Here's my picture, right? Here was our parabola, went something like this. When it hits the ground is right there. Remember, this was time and this was height. And when it hits the ground, my height is 0. So I'm looking for a 0. And there are two things that helps me find a 0. I can use quadratic formula. Quadratic formula helps me solve a quadratic equation. Anything in an x squared. So, oops, I'm writing x and I shouldn't. Quadratic formula is the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And I'm going to go write down our equation that we were working with. Our equation for this was -0.05 x squared plus 3x Oh no, that wasn't it. Sorry guys, I'm lying to you. It was negative 16x squared plus 64x plus 190. Let me scroll up and make sure I got the right equation. Okay, good. All right, so we're going to use the quadratic formula to find the zero. My value of A is negative 16. My value of B is 64. My value for the opposite of B is a negative 64. My value of C is 190. So we're going to start plugging in. The opposite of B is negative 64, plus or minus the square root of 64 squared minus 4 times a negative 16 times 190. And this is all going to go over 2 times the negative 16. All right, let's start simplifying. I end up with negative 64 over, I'm going to square 64, and when I square 64, I get 4,096. And then I know I'm going to plug in my calculator a negative 4 times the negative 16 times 190. A negative times a negative is a positive, and I end up with 12,160. And this is all going to be over a negative 32. So we're going to combine those two. Oh, I forgot my plus minus sign. Negative 64 plus or minus the square root of a pretty big number. It's 16,256 all over negative 32. All right, I'm going to come down here and finish our work. Let's do negative 64 plus or minus the square root of 16,256 is 127.5. And that's all over negative 32. So this splits into two answers. One of my answers is negative 64 plus 127.5 all over negative 32. The other answer is going to be negative 64 minus 127.5 all over negative 32. So in your calculator, I want you to add those two numbers. You should get 6350. I'm going to extend our page here. You should get 6350 over negative 32. When you add these two numbers together, you should get negative 191.5 all over a negative 32. So 63, this should be a 6, guys. 6350. This is negative 0.198. And this becomes 5.98. So what does this mean? This means my object is at, this doesn't make sense, 0 feet high, right? It means it's on the ground. It's on the ground at negative 2 seconds and at 5.98 seconds. Well, negative 2 seconds doesn't make a lick of sense because we can't go back in time. So this thing hits the ground at 5.98 seconds. I'm going to go grab the graphing calculator and I'm going to show you how to find a zero. All right, we're going to go back in. Y equals, my equation is there, hit graph. We want to make sure that we can move our cursor above the x-axis and below. So I'm going to go ahead and change my y min to possibly negative 10 and hit enter. And now hit graph. I'm going to go a little more. Maybe I'm going to, I'm sorry, not the x min. No, the y min, that's what I wanted to change. Negative 20. Enter. Let's hit graph. All right, I'm able to see it. So to calculate the zero, here's your minus 2 that doesn't make sense. To go find our other zero, zero is an option. My cursor is above the x-axis, so I'm going to hit enter and say yes. Now you need to bring it below. I want you to watch. Notice my y value is changing. It's getting bigger. It's getting smaller. You want that y value to be less than 0. I see it went negative. That's what your calculator is looking for. Hit enter. And it says my 0 occurs at 5.98. That's exactly what we calculated. Okay? So that's how we did that problem. I'm going to go on and do another one. This is going to be a long video, but you can fast forward. We're going to do this second problem. The second problem, you're going to want to know how to do. Okay? So I can throw a frisbee. I bet you didn't know that. And I have been taking lessons, and I perfected my technique. And that frisbee goes in a beautiful arc. It goes in a rainbow. So I'm pretty talented. I even went so far as to have somebody get me a model. And this equation right here models the height of my frisbee. It actually models the height of my frisbee and the distance traveled. So this is a little different. This is different from our other problem. I'm going to sketch a picture. So this is what's interesting. I get the height. That's my frisbee. I'm running out of room here. I'm going to move that over. Okay, so what's different from the earlier problem, this is the height. This is how high my frisbee goes, but this is distance traveled down here. This is distance away from where I threw it. This isn't time anymore. This is distance traveled. So we're going to do the same thing. What is the maximum height of my throw? So I'm going to use the graphing calculator to calculate this, okay? Actually, I'm not. I'm going to do this the old school way. So the maximum height is going to be, when I'm looking for a maximum, I'm looking for the vertex. So I need to use the opposite of b over 2a and plug that in. So the opposite of b is a negative 3 over 2 times a negative 0.05. So I get negative 3 divided by negative 0.1, and that turns out to be 30. So my x value of my vertex is 30. Now I'm going to go plug 30 into my equation. So my height, when my frisbee is 30 feet away from where I threw it, is negative 0.05 30 squared plus 3 times 30 plus 2. And how does this work out? This calculates to be 47 feet. So if you put this in your calculator from left to right and use the parentheses, you should get 47 feet. So the maximum height of my throw, that's 47 feet. Okay? I'm going to go drag my next question up here. My next question says, at what distance did the frisbee reach its maximum height? When it was 30 feet away from where I threw it. So I'm going to say that. When it was 30 feet away from where I threw it. Okay, so that is its distance. Since you guys have been getting pretty good at this, we're going to add a couple more questions here. Our next question is this one. So I've got a light pole that runs through my backyard. And is this frisbee going to get in the way? So I'm going to go grab this equation right here, and I'm going to copy it down here for us. And I'm going to go get our picture. So that's our equation, and this is our picture. So Copy. All right, so here's the deal. I've got a light pole that runs through my yard. It's in my backyard, and I want to know what is the closest distance that that Frisbee can hit the light pole. So basically, what this means is this light pole is represented by this line. This is the light pole. And the light pole's sitting here at 35 feet high. And I want to find that value. That's the closest distance. This is the farthest distance. I don't want to find the farthest, I want to find the closest. So I'm looking for an intersection. And the way that we find an intersection is we use quadratic formula, but we use this value. So what we say is, when does 35 feet intersect my curve? What's the equation of my curve? That thing. Negative 0.05 x squared plus 3x plus 2. Now you're going to ask, how do we solve that? Just like how we solve every other equation. We're going to subtract 35 from each side, and we end up with 0 is equal to negative 0.05x squared plus 3x minus 33. So how do we solve that? We've got two methods. We can try to find two numbers that multiply to that product that add to 3. That's not going to happen. So what's your suggestion? I knew it. You were going to say quadratic formula. We're going to use quadratic formula. That's going to allow us to figure out this point. So QF says take negative 3 plus or minus the square root of 3 squared minus 4, negative 0.05 times negative 33, that's all under the radical, all over 2 times negative 0.05. Okay? So when we compute this piece, we get negative 3 plus or minus the square root, and I end up with 9 minus 6.60. This computes to 6.60. All over 2 times that, so I get a negative 0.1. All right, I'm going to extend my page, and we're going to have a little bit more room to work. So let's go through now, and let's calculate this. We get negative 3 plus or minus. That's going to be the square root of 240. That turns out to be 1.55 all over negative 0.1. And this is going to split us up into two equations. One of my equations is negative 3 plus 1.55 all over negative 0.1. My other equation is going to be the minus. Negative 3 minus 1.55 all over negative 0.1. When you compute this calculation, you end up with 14.5. When you compute this calculation, you end up with 45.5. So if we go look at our picture that we drew, I'm going to just redraw it down here. Here's my light pole. This intersection is at 14.5 feet away from where I threw it. This intersection is 45.5. So which was the one I wanted? 14.5. So I can answer this by saying at 14.5 feet. That's what I'm going to end up hitting my light pole. You can do this with your graphing calculator. Let's check our work, and we're going to use an intersection. So I'm going to sneak this back in. Let's turn it on. Go to your y equals, hit clear. We're going to type in our original equation. Let me go find that. All right, our original equation, negative 0.05 x squared plus 3x plus 2. Hit enter. Let's go graph it. It's kind of messed up because of my viewing earlier. So let me go to my window. I know I'm up way too high. So my y max what was my maximum of this thing? My max was 47. Let's make my y max 50. And let's count this thing by 5s. And maybe we're going to start at -10. And then let's talk x values. I can't go negative time, but my vertex was over at 30, wasn't it? 30, 47. So maybe I make this 75. And I'm going to count by 5s. All right, that looks a lot better. That's me throwing the frisbee. So let's go find, we're looking for this value over here. How do I put in the height of my light pole? You're going to go down and do y equals 35 and hit enter. And now let's go look at your graph. We want to find this intersection point. So how do we do that? Second, trace. First curve, it's asking me, see there's my blinky cursor. What curve do I want to use? This one. Enter. Oh, what did I do? I want second, calc. I want to find my intersection. Intersect. So first curve is this curve. Enter. Second curve is my line. Click enter. It says guess. I get 14.5, which is exactly what we calculated. So that's the 2 ways that you can do this. All right, I know this was long, but it's going to help you with your final, okay? If you have any questions, you can always ask me in class. Have a good night.